Hello everyone! In every laboratory activities and calculation in chemistry, certainty is everything. To obtain the correct answer with the most certainty and to achieve the exact product based on the calculations, certainty is very important. For us to obtain the highest level of certainty possible, we have what we call significant figures and rounding off. Significant figures. Significant figures are the numbers of digits in a value, often a measurement, that contributes to the degree of accuracy and certainty of the value. In measuring and calculating several and different quantities, typically, the results in data contains different numbers of significant figures. First of all, you need to know how to count the numbers of significant figures. For this, we have 4 general rules. The first rule: all non-zero digits and any zeros contained between non-zero digits are significant, meaning all numbers from 1 to 9 are significant. The example, 40067. It has 5 significant figures because the 2 zeros between the non-zero digits are considered significant. The second rule, leading zeros are not significant, meaning all zeros that leads the number are not significant. Example, 0.00036. It has 2 significant figures, as the 4 zeros that leads the numbers are not significant. The third rule, trailing zeros are significant if there is a decimal point, meaning all zeros that trails the number are considered significant only if there is a decimal point. Example, 0.0003600 has 4 significant figures, as the 2 trailing zeros are considered significant because there is a decimal point. The fourth rule, trailing zeros may or may not count as significant if there is no decimal point. So, we go with the most conservative answer. Example, 170000 has 2 significant figures. Since there is no decimal point, and since we'll go with the most conservative answer, we have 2 significant figures, as it could be written as 17 times 10 raised to the 4th power, where you can clearly see that we have only 2 significant figures. Now for a quick review. 74562 have 5 significant figures, as all non-zero digits are considered significant. 70006 have 5 significant figures, as all zeros contained between non-zero digits are considered significant. 0.0656 have only 3 significant figures, as all leading zeros are not considered significant. 0.00500 have 3 significant figures, while the leading zeros are not considered significant. The trailing zeros are considered significant if there is a decimal point. 1650 have only 3 significant figures, as the trailing zero is not considered significant because there are no decimal point. 1650 point have 4 significant figures, as the trailing zero is considered significant since there is a decimal point. 0.00670500 have 4 significant figures, while the 3 leading zeros are not considered significant. The 0 between 7 and 5 is considered significant because it is between non-zero digits, and the 2 trailing zeros are considered significant since there is a decimal point. Since now you know how to count significant figures, let's proceed. During calculations, we need to keep track of the number in each quantity so that we don't have more significant figures or more certainty in the answer than in the data. If we do have too many significant figures, we must round off the answer. Since you usually need to round off the final answer to the proper number of significant figures or decimal places, we need to have a quick review about the rules of rounding off. The first rule: if the digit removed is more than 5, the preceding number increases by 1. Example: 7.267 becomes 7.27 if you need 3 significant figures, and becomes 7.3 if you need 2 significant figures. Number 2. If the digit removed is less than 5, the preceding number remains the same. Example: 0.3412 becomes 0.341 if you need 3 significant figures, and becomes 0.34 if you only need 2 significant figures. Number 3. If the digit removed is 5, the preceding number increases by 1 if it is odd and remains the same if it is even. This rule only works if 5 is the last non-zero digit. For example, 18.55 becomes 18.6 since the preceding number is odd, so it will be added by 1. Another example is 18.65 becomes 18.6 since the preceding number is even, so it will stay the same. Always remember that this only works if 5 is the last non-zero digit. But if it is followed by a non-zero digit, follow the first rule and add 1 to the preceding number. For example, 18.65134 becomes 18.7 since 5 is followed by non-zero number, so the even preceding number will be added by 1. Number 4. Always carry 1 or 2 additional significant figures through a multi-step calculation and round off the final answer only. Now, you know how to count significant figures and know how to round off. So, let's proceed for the rules of significant figures for arithmetic operations. For multiplication and division, the final answer will contain the same number of significant figures as there are in the measurement with the fewest significant figures. Meaning, the measurement or the number in the calculation that has the lowest number of significant figures will determine the number of significant figures your answer will have. Example: 12.34 times 2.1 is equal to 25.914. But since the number with the lowest amount of significant figure is 2.1 and has only 2 significant figures, the answer will also have 2 significant figures and will be rounded off to 26. The same rule will apply in division. For addition and subtraction, the final answer will contain the same number of decimal places as there are in the measurement with the fewest decimal places. Meaning, the measurement or the number in the calculation that has the lowest number of decimal places will determine the number of decimal places your answer will have. Example: 12.34 plus 2.1 is equal to 14.44. But since the number with the lowest amount of decimal places is 2.1 and has only one decimal place, the final answer will also have only one decimal place. So it will be rounded off to 14.4. The same rule will apply in subtraction. Now for a quick review. 11.3 times 4.6738 is equal to 52.81394. But it will be rounded off to 52.8 since 11.3 have only 3 significant figures. 15.37 minus 4.5683 is equal to 10.8017 and will be rounded off to 10.80 since 15.37 only have 2 decimal places. 15.96 divided by 3.7344 is equal to 4.2737789, but it will be rounded off to 4.274 since 15.96 only have 4 significant figures. 50.78 plus 71.3 is equal to 122.08, but it will be rounded off to 122.1 since 71.3 only has 1 decimal places. Congratulations! You now know how to count, round off, and calculate significant figures. Thank you for listening. Goodbye!